Hello everyone, let us solve the following. A 1.5 meters tall boy is looking at the top of a temple which is 30 meters in height from a point at certain distance. The angle of elevation from his eye to the top of the crown of the temple increases from 30 degrees to 60 degrees as he walks towards the temple. Find the distance he walked towards the temple. Okay, so the problem seems big. Let us see in the form of an image. There is a temple of height 30 meters. Okay, a boy of height, uh, 1.5 meters is walking. Okay, towards the temple. Okay, at his initial position, the angle of elevation of that particular boy to the top of the crown of the temple is 30 degrees. After walking certain distance, d meters, say suppose it is not given, and his initial position and the distance between the temple and the boy is also not given. Nothing is given. Only it is given about the boy's height and the temple height and two angles of elevation. Okay, so first initial position 30 degrees. After walking some certain distance, the angle of elevation is 60 degrees. Okay, these two are given. We need to find out how much distance the boy has walked. Okay, to attain the second position. Only that one should be found out. Okay, right? So let us see here. This is the boy's, this is the temple height 30 meters, and the boy's height is 1.5 meters. So the effective height that the boy could see is 28.5 meters, because we need to subtract the height of that particular boy, because his angle of elevation is given from his eye. Okay, that's why we need to consider this height also. Okay, so at the initial position, the boy has an angle of elevation of 30 degrees, and after walking certain distance that we are going to find it out, after walking that distance, okay, the boy has the angle of elevation of 60 degrees, right? So here only one point that we have found it out, that the effective height the boy could see, effective height of the temple that the boy could see is 28.5 meters. This should be noted down. Okay, we have subtracted the height of the boy from the height of the temple, as we are considering the angle of elevation from his eye. Okay, clear? If this point is clear, it is easy for us to find it out. Okay, so here the boy has walked certain distance, d meters. Okay, but that d meters only we need to find it out. Clear? Right. Now coming back to the solution. So it is given height of the temple is 30 meters, height of the boy is 1.5 meters, effective height seen by the boy is 28.5 meters. That is 30 minus 1.5. The height of the temple minus height of the boy. Okay, right? So initial angle of elevation is 30 degrees and final angle of elevation is 60 degrees, right? And we know that tan 30 is equal to 1 by root 3 and tan 60 is equal to root 3. Okay, now first we are going to consider the first angle of elevation. That means the initial position of the boy we are considering. Initial position of the boy means we know boy's height, we know, and the temple height we know, and we don't know about the distance between the boy and the temple. Okay, let us consider it as x meters. Okay, so for the initial angle of elevation, tan theta is equal to opposite side by adjacent side, that we know. From the initial position or the first position, tan 30 is equal to 30 degrees. So when we are taking opposite to 30, opposite angle, opposite side becomes the effective height of the temple, not the height of the temple, effective height of the temple. Okay, that is 28.5. And adjacent side becomes the distance between the boy and the temple. We don't know it, we have considered it as x meters. So tan 30 is equal to 28.5 by x. Obviously x becomes 28.5 into root 3. Let us consider it as first equation. Okay, x is equal to 28.5 root 3. That is the actual distance from the boy to the temple at his initial position. Okay, but it is not asked in the problem. It is asked about the distance that the boy has walked. to get the second position. Okay, so for that we are considering now 60 degrees, second angle of elevation. Okay, so let us consider, let the distance after walking be x minus d. D is the distance that he had walked. So second position, to attain second position, he might be at the distance of x minus d. Okay, right? After walking, the angle of elevation is 60 degrees, right? So tan 60 is equal to 28.5 by x minus d. What do we know? Tan 60 is equal to root 3. Root 3 is equal to 28.5 by x minus d. Right? So x minus d becomes 28.5 by root 3. Right? X minus d becomes 28.5 by root 3. So we need to find out d, the distance that the boy had walked. Okay. So d is equal to, obviously, what does it become? X minus 28.5 by root 3. D comes this side, and obviously d is equal to x minus 28.5 by root 3. Okay, so what do we know? X value we know from the equation 1. X is equal to 28.5 into root 3. From equation 1, by using the first angle of elevation, we have found it out. Okay, so now x is equal to 28.5 into root 3. Just we are substituting x value there. So d is equal to 28.5 into root 3 minus 28.5 by root 3. Okay, now let us do the simplification. In both the terms, we have 28.5 common. So we have take it out as common. 28.5 into root 3 minus 1 by root 3. After taking LCM, after simplifying it, what did we get? D is equal to 57 by root 3. We got the value. What is the D? The distance that the boy had walked. Okay, right? So D is equal to 57 by root 3. Further simplification we can do directly. We can substitute 1.7, the root 3 value is 1.732. But divide it becomes a little bit tough. So for simplifying it, what we can do, we can multiply it with 1. 1 means root 3 by root 3 here. We can take. So 57 by root 3 into root 3 by root 3. So finally it becomes 57 by 57 into root 3 by 3. Okay, so finally 19 into root 3. Now we can substitute root 3 value. Root 3 is equal to 1.732. So D is equal, so D is equal to 19 into 1.732. That is approximately equal to 32.9. So the distance that the boy had walked is 32.9 meters. Okay, right? Yes. Don't forget to share, like, and subscribe. Thank you.